We're just going to continue talking a little bit about the organic there in terms of naming. We talked about how to properly sort of name things, especially alkanes. Let's look at maybe a couple other examples. Let's do this one here. Let's do let's try a little line structure action. Why not? I feel like I just drew a shape, so let's see. All right, give those a go. So follow those rules. We'll try one that's a line structure. We'll try one that's condensed. I'll try it as well, and hopefully I didn't mess up. So we'll start with the top left one. Again, we want to go for the longest carbon chain. So there's many ways you get it in this particular one, but it should be 3 no matter which way you go. You could go straight to get 3. You could go straight and then up. You could go straight then down. You could start at the bottom and go to the top, by the way, and be 3 as well. So since we do have that option of just going straight across, we might as well just go with the straightest one there. Remember that that longest continuous carbon chain is going to give us our base of our name, and that has 3 carbons, which, as we talked about previously, should tell us that the kind of base there of our name should be propane. We also have 2 groups that are attached here that are not part of that main chain, and they both are those 1 carbon groups, which is based off of methane. So this would be a methyl group, and this would also be a methyl group. That also means that in this particular compound, I have 2 of the same groups, which means we do actually need to use a prefix here. And that would be like a dimethyl action sort of happening here. It is not because, again, it is not because that they happen to be on the same carbon. It just means that there's 2 in that molecule. So they could be on the same carbon, they could be on different carbons, but because there's 2 of them, we do use that prefix of di. If we had 3 of them, we would use tri, and if we had 4 of them, we would use something like tetra or something like that. Now, the next thing that we need to do is number the longest carbon chain. And again, we're going to, in this case, go left to right or right to left. And as you probably can tell, it's not going to make a tremendous difference depending on which way we go in this particular case. That's going to be carbon 1, carbon 2, and carbon 3. The other option would be to go the other way around. In this case, no matter which way you go, we got both of those groups sitting at carbon number 2. Which means this is really a 2-methyl and a 2-methyl. And that's really all we need now for the name. We just need to put it together. Now, because they are still on the same carbon and they are still 2 different groups, even though they're the same group, but 2 groups located there, we do need to give both names. So this would be a situation where we would go 2, 2 to indicate that those groups are on carbon number 2. We would go dash. The next thing that would come would be the groups part of the name, which would be dimethyl. And now we will finish it up with the base of the name here, which would be propane. Question on that one there. All right, looking at our line structure here, longest carbon chain in this case is how many? So if we just go straight across, that is 1, 2, 3, 4, 5, 6, and 7. I have a feeling that's going to be the winner there. We could go starting here, 1, 2, 3, 4, 5, 6, which is less, obviously coming up that way. The other option would be 1, 2, 3, 4, 5, and 6 that way, which is obviously less. Your other option would be 1, 2, 3, 4, which would be less. And obviously your last option would be 1, 2, 3, 4, 5, and 6, which would be less as well. So again, it never hurts to check all of your options. You never know when one might be hiding in there. that you might have missed. But in this case, it does look like the straightest one will be our longest carbon chain. And in this particular case, that means it was 7, right? So the base of our name here should be heptane, right? In this case, we actually have 2 groups also attached. We have a group that is right here. We have this group, which is a 1 carbon, 2 carbon group. And this guy, which is just a line with nothing at the end of it, which means it's a carbon that has 3 hydrogens, which is a methyl group. So in line structure, if you see a line with nothing at the end of it, like we see here, that means at the end of that line is a carbon, and there should be the appropriate amount of hydrogens, which in this case would mean that this guy is what group? That is a methyl group, as it has 1 carbon. This guy has 1 carbon, 2 carbons, which means it is a ethyl group. Yeah, so that is how we need there. Now, if you have line structure and there is a line and they want something other than carbon there, they will put it. They'll put like a bromine or whatever it may be. They will actually put something there. But if you just see a line and line structure and it just kind of ends, nothing there, it's assumed to be a carbon. In most cases, it'll be a methyl group with 3 hydrogens that are attached. Question on that? By the way, this group here, by the way, are halogens, which can be attached to alkanes. They're named kind of like you might imagine. Cl is chloral. F is fluoral. You kind of put an oral at the end of those guys. Br is bromol. And I is iodo. So those have their special sort of names as well. This would be actually a bromol group. And again, like I said, if you had fluorine, it would be a fluoral. Cl would be a chloral type of group. I would be a iodo group type of thing. So those are how you would name sort of halogens that do oftentimes sort of show up on a alkane. All right, but back to the one that we have drawn here. We'll get rid of some of this here, so we have somewhere to write. Okay, so now that we have our groups identified, we're to the part where we do need a number. So in this case, we could go left to right. That would be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, and carbon 7. If we number the other way, I'll do it below. 1, 2, 3, 4, 5, 6, and 7. So going the blue way here, we have groups at carbon number 3 and carbon number 4 is where we have groups located. Going the black way here, we have groups at carbon number, looks like 4 and carbon number 5 in this case. So now we actually do have some difference, right, in terms of which way we number it. The way we should number is which way? We should go in the blue direction. It is as simple as 3 is less than 4. This is that simple. So in this case, because 3 is less than 4, we would want to go in the blue direction here in terms of our numbering. And if we do that, that means that going in that blue direction, at carbon number 3 is where we would find our methyl group. And at carbon number 4, there is where we would find our ethyl group. Yeah. Obviously, we'll get rid of this way in terms of numbering. Any questions on that? All right, so now we pretty much got everything that we need. We're going to put our groups in alphabetical order, regardless of number, which means which group should come first here? Should come first is the ethyl group. Even though it has the larger number, it doesn't matter. It should be alphabetical. So this name here should end up being 4-ethyl. Next group would be our methyl, 3-methyl, and then we will attach the last part here to our name, which will be heptane. That is a mouthful. Yeah, so that is 4-ethyl, 3-methyl heptane. Again, basically what that name means is heptane, you got 7 carbons in a row. And if you go to carbon number 3, you should find a methyl group. And if you go to carbon number 4, you should find a ethyl group. Question on that naming part. So let us, now that we sort of did a couple more examples here of naming, let's also talk about how we go from a name to drawing it, which is also really important. And also, in my opinion, the easiest thing to do is actually to go from the name to the drawing. So let's talk about how we would go about sort of doing that. So let's just do, I don't know, let's do 3-methyl. Actually, let's do that work. Let's do 3-methyl 4-propyl. I am just making this up, so let me make sure I got enough carbons here. Let's go with octane. Why not? That should definitely be enough. All right, I'm going to regret it in a minute, but that is octane at the end of that. All right, so we have this guy here that we want to draw, 3-methyl 4-propyl octane. Whenever you have the name and you want to draw it, you always want to work backwards. So you always want to work backwards in the name. So if you do that, we're going to start this way. And that is really the first thing that we're going to start with, which is octane, which means how many carbons? That is why I'm regretting it. And now what I'm going to draw is just the carbons, nothing else. So I'm just going to draw the carbons, nothing else. Just basically 8 carbons in a row. I'm going to leave a little space because I'm going to add some hydrogens in probably. So that's 1, 2, 3, 4. I'm halfway there. 5, 6, 7, 8. Good thing I didn't go decane. All right. So that is 8 carbons. That pretty much takes care of this part of the name. I am done with that. Now, the next 2 parts of the name are the groups that are attached to these 8 carbons, and the numbers tell us where they are attached. So basically, when we see 4-propyl, that means that we go to carbon number 4, and we should draw a propyl group. And since you are drawing it, it is up to you which way you want to go. You could number the guy on the left as carbon number 1. You could also number the guy on the right as carbon number 1. Because you are drawing it, it is your choice. I'm going to choose the guy on the left as carbon number 1. And because I did that, that means as I go left to right, it's going to be 2, 3, 4, and so forth. So that is what I'm going to do. I'm going to go to carbon number 4, which should have a dash between that. So carbon 1, carbon 2, carbon 3, carbon 4, which would be right here in my direction. I'm going to attach a propyl group, and a propyl group should have how many carbons? 3, because it's based off of propane, right? So we're going to do 1, 2, 3, and frankly, I'm just going to do the carbons as well. And that pretty much takes care of that name. By the way, you could have drew it on the bottom too. It doesn't matter. It could go top or bottom. It doesn't really matter. Also, we see here that at carbon number 3, I have a methyl group. Because again, I carved this carbon number 1, that means my carbon number 3 has to be that guy right there. And here I will attach a methyl group, and that's based off of methane, which means it should have just 1 carbon, right? I am pretty much out of name at this point. So everything else here is just hydrogen. And the goal here, the important part is carbon needs to end with 4 bonds. So we're going to add the appropriate amount of hydrogens to make sure each carbon in this picture ends up with 4 bonds. I'm going to do the condensed formula, so I'm not going to draw out the hydrogens in the expanded formula. So I'm just going to do my H's as sort of condensed. The guy here at the end has 1 line coming in, which means in order to give this guy 4 bonds, it needs 3 hydrogens. The guy next to it has 2 lines, 1 on each side coming in, which means it has 2 bonds already. To get it to 4, it needs 2 more hydrogens. Guy next to it is identical, needs 2 more hydrogens. Same thing with the guy next to it, although it looks like a double bond. That's just a single bond there. So 1 and 2 bonds coming in gives us 2. How about carbon number 4? How many hydrogens should it have? Should just have 1 because it has 1 line coming in here, 2 coming in here, and 3 coming in here, which means it just needs 1 hydrogen. Same thing with carbon number 3. It has 3 lines coming in, which means it has 3 bonds, which means it also just needs 1 hydrogen. I'm gonna get rid of my original 4 and stuff so don't look all weird. All right, and continuing on to the left, actually we'll get rid of that one too. And super zoom. So this guy has 2 coming in, which means it needs 2, and this guy has 1 coming in, which means it needs 3. I still need to fix my guys up on top. Guy up on top left has 1 line, which means it needs 3. That makes our methyl group. Guy over here needs 2 because it has 2 lines. Guy here needs 2 because it has 2 lines. And guy here needs 3 because it has 3 lines, or 1 line. And now we have basically our picture here. Yeah. So you always want to kind of start backwards. You want to just put the carbons in and then basically just finish up with hydrogens to get everybody to 4. Any questions on that there? In this case, when you're drawing it, it doesn't matter. So if you decided for yourself that over here was carbon number 1, you would need a number in this case this way, which means really your methyl group would end up on this carbon, and then your propyl group would end up over here. So it is really the same molecule regardless of which way you go, because frankly, all you did was just turn it. So if you just turn the one I drew, it would become the one that if you went the other way. Yeah. Yep. Other questions? Now, if I wanted this guy in line structure, right? Now that I kind of have it like this, I could draw line structure, and we would have 8 kind of zigzags. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 8. And again, at carbon number 3, we would have a methyl group, which would just be a line. And at carbon number 4, we have a propyl group, which will look something like that, right? So that would turn it into a line structure. My organic teacher would be mad, I know. So there we go. I'm gonna fix it up a little bit there. Any questions on how to do that there? All right, so I drew 1. Why don't you draw 1? Let's try, let's do, let's go with 2-ethyl, 3,4-dimethyl. Let's go with hexane. All right, 2-ethyl, 3,4-dimethyl hexane. Okay, let's take a look at this one. So once again, we're going to go backwards here. So we're going to start with hexane, which means I should lay up here 6 carbons. That takes care of that part. Now carbon 3 and carbon 4, I have a dimethyl group, which obviously means that there are 2 methyl groups in this compound, 1 at carbon 3 and 1 at carbon 4. Again, I'm going to call this carbon number 1 for me, and I'm going to go to the right, which means at carbon number 3, I should have a 1 carbon group, and at carbon number 4, which would be right next door, I should also have a 1 carbon group, and that will pretty much take care of those things. I then also have a 2 carbon group at carbon number 2, which is our ethyl group, and that should take care of that. And again, at this point, everything else will be hydrogens. So this will be 3 hydrogens, 2 hydrogens, 1 hydrogen. This guy up on top should have 3, which gives us our methyl groups. So should this one. This guy has 3 lines, which means it needs just 1. That also has 3 lines, which means it needs 1. Guy at the end should need 3. And 3 for this guy, and squeezing in 2 for that guy there will give us our condensed structure here. Yeah. Any questions on that there? All right. Any questions on how to draw from name? It really is the easiest sort of thing to do. Let's talk about one last thing here, which are cycloalkanes, which are those ring structures we talked about. And a lot of times they are drawn as sort of line structures. So you got some of these geometrical type of shapes a lot of times. So if we count up these carbons here, this has 1 carbon, 2 carbons, 3 carbons. So 3 carbons in a ring type structure is still based off of propane, But for these cycloalkanes, which is what these are called, we add cyclo to the beginning of the name. So this is cyclopropane. This would have 1, 2, 3, and 4 carbons, which would be cyclobutane. This would have 1, 2, 3, 4, 5 carbons, which is based off of pentane. This would be cyclopentane. This would have 1, 2, 3, 4, 5, and 6 carbons, which would be cyclohexane. Now, if we were to draw sort of the condensed formula for these, it would look something like this. Remember, we would have our hydrogens there. That would be more of the condensed formula for it. And obviously, for say something like this guy, it would look like this. Now, if you do have a group attached to a cycloalkane, so let's just say we had something like this, a square with a line at the end of it. We still would follow kind of the same rules that we did before. The longest continuous carbon chain in this case would actually be the cycloalkane. And that would still be the base of our name, which in this case, because it is our 4 carbon guy, our square, the base of our name here would be cyclobutane. We still would find the groups that are not immediately part of those 4 carbons, which actually would be just this line. And that line has a carbon at the end, which should have 3 hydrogens. And that would be our methyl group, right? So again, this line with nothing at the end of it is our methyl group, basically our CH3 group. So because this is the only group attached to this cycloalkane, we just basically use the group name in front. We do not need to give a number or anything like that, because wherever that group is at is assumed to be carbon number 1. So this would be methyl cyclobutane. Any questions on that there? Now, if we did have 2 groups attached, let's just say we had this guy with a line and maybe a Cl there, right? So in this case, the longest continuous carbon chain would still be our cycloalkane, which in this case is our triangle, right? And that's going to be our cyclopropane. But now we actually have 2 groups attached to this. We have our methyl group, which is just a line. And we also have our chlorine group here, our chloral group. So we have actually 2 different groups attached. Once again, this is a methyl group. This is a chloral group. We do need to put these in alphabetical order, but because this is what is sometimes referred to as being di-substituted, meaning 2 things are attached, we do have to give the numbers of this, right? So we basically could go one of 2 ways in terms of the numbering. If we make our triangle really big, right? We could start with the methyl group, and this would be 1, 2, and 3. We could start with the chlorine group, and this would be 1, 2, and 3. We could also go the opposite way, which would be 1, 2, and 3, which would give us a much larger number, 1 and 3, versus a 1 and 2 situation. So we wouldn't want to go this way for sure. Which one should get the 1 in this case? Alphabetical, which one should come first? The chlorine, yeah. So because the chlorine should come first, and there is no real difference in terms of which way you would number those guys, you would probably want to start with the chlorine and go this way, which means we would have 1 chloral, 2 methyl cyclopropane. Yeah. So if you have just one group attached, it doesn't really matter in terms of the number. It's assumed to be group number, carbon number 1, which means you do not need to put the number on it. But if you do have multiple groups, you do need a number. And again, whichever way gives it the smallest number. And if it is sort of a tie, no matter which way you grow, then you want to default back to alphabetical and give that alphabetical guy the smaller number. Any questions on that one there? All right, we will